Experiment. To draw the calibration curve d lambda of a spectrometer with a given prism and hence to find the wavelength of some unknown lines. For this experiment, you will be needing a spectrometer, a spirit level, a prism, a sodium lamp transformer. You will be also needing a helium lamp and a neon lamp for an unknown wavelength. First, we start this experiment by heating the sodium lamp through connecting via a sodium lamp transformer. Then we level the spectrometer using a spirit level. First, we level the base of the spectrometer using a spirit level. Then we measure this prism table using a spirit level. Then this is the colorimeter. We also level this using a spirit level. And this is the telescope through which we see the lines, spectral lines. We also level this one. Now, how to observe the spectral lines? First, we see through this first colorimeter through which the light enters. Then we see the light, a small spectral line will be visible. A thin line should be produced through this colorimeter. Next step is placing the prism. As you can see, this prism has three sides. The one side of the prism is opaque. The opaque side should be kept at your left side. See here the prism table, and you see a line here. You place the prism on this line, and the opaque side to be this side. Now we have to find the minimum deviation of the sodium light through this prism.
The next step is to find the position of minimum deviation. How can we find the position of minimum deviation? In order to find the position of minimum deviation, we have to rotate the base of the spectrometer and simultaneously observe the spectral line through the telescope. In order to take the reading, we have to adjust the spectral lines in the minimum deviation position. That is, the position where the spectral lines moves towards the opposite direction. Once we start rotating the base of the spectrometer either in clockwise or anti-clockwise direction, here we are rotating it in an anti-clockwise direction. When we start moving the base of the spectrometer, the spectral lines also starts moving, and after reaching a certain point, the line starts to move back or return back from that position, and that position is known as the position of minimum deviation. In order to take the reading of minimum deviation for sodium light, we have to place the cross wire in the minimum deviation position.
In order to take the reading for the minimum deviations, we need to refer to the two scales, reading 1 and reading 2. Now you need to replace the sodium lamp with a helium lamp. Now this is the helium source. Now this helium source needs to be connected to a high voltage source. When you see through the telescope to the eyepiece, you will see these spectral lines of helium. As you can see the spectral line of the helium, in order to take the reading, you have to place the crosswire on each spectral lines and take the reading which is on the base of the spectrometer. Similarly, replace the helium with the neon tube. Similarly, you will find the respective spectral lines of the neon and take the reading accordingly. After completing the neon, you have to replace the neon with a sodium lamp and find the direct rays. In order to find that, you have to remove the prism. place the collimator and the telescope linearly in order to take the direct reading. This is the spectral lines of the sodium lamp. This is the direct rays, and now take the reading of this. How to take the reading? In order to take the reading, this is the table for the helium spectral lines. As you can see here, the first reading and the second reading. In order to take the first reading, you need to refer to the spectrometer, the first reading, and for the second reading, this is the scale. Similarly, you can take the readings of red, yellow, green, and all other table respectively. Now, after taking all this data, you need to plot the graph and find the wavelength of neon red and neon orange, and this is your result.